In this video, we're going to manually work out the quartiles for a set of data or a set of scores. Just quickly, quartiles are values that divide an ordered, that's very important, an ordered set of scores into 4 equal parts. Now, recall, what do you call a value that divides an ordered set of scores into 2 equal parts? Begins with M, something that means the middle. What do you call that strip in the middle of the road? Median strip, okay? So the median is going to be important here. So let's have a look at this example. Find the quartiles for the data set shown. So 5, 1, 2, 5, 7, 8, 3, 1, 9. First thing we need to do, it needs to be ordered, okay? So let's order it. So we've got 2 1s, so 1, 1. Okay, so normally when I order them, you either can put a little, a mark above them or something like that just to show that you've used them up. We've got a 2, okay? Any other 2s? We've got a 3. Okay. We've got 2 5s. So 5, 5. And we've got a 7, 8, 9. Alright. First thing we need to do is we need to find the median. Alright. So, in fact, the median is fairly straightforward to find. The median is going to be the middle number. There's an odd number of numbers. So the median is 5. Okay. Now the median is also called Q2. It's a second quartile. Okay. The median, which is designated Q2, second quartile, that's equal to 5. And I might just maybe draw an arrow there. So this is what we call Q2, or the second quartile. Now, since we've used up that 5, now we need to find the lower quartile, or quartile 1. We also need to find quartile 3. So now we consider each half, okay? The half below Q2, and then the half above Q2, and each one of these halves, we need to work out the median of each one. So the median of the bottom half, okay, so this is Q1, okay, so Q1, right, is equal to, well, because we have an even number of numbers, we need to take the mean of the middle 2 numbers. So that's going to be 1 plus 2, okay, over 2, which is equal to 1.5, okay. Alright, so that's, I might just put an arrow in there, so it's between them. Alright, so that's Q1 is equal to 1.5. Okay, so basically sits in between those two. Okay, what about Q3? So Q3 is what we call the upper quartile. Okay, so I'll just put lower here. Now we need upper, and we've got the same issue here. We have an even number of numbers in these top 4 scores, so it's going to be the mean of 7 and 8. Okay, so 7 plus 8 over 2, okay, and that's equal to 7.5. Okay, and this is the upper quartile. Okay, so that's Q3, and that's equal to 7.5. So these 3 values, Q1, Q2, and Q3, separate the data into quarters. Okay, and that's it. We'll look at later on what does this mean. So if I was to say find the value that separates the top 25% of the data from the bottom 75% of the data, you would say Q3. Okay, so think of these quartiles as separators. By the way, the calculator does have a function to be able to work out Q1, Q2, and Q3 automatically for you. All you've got to do is just give it the data and it'll order it for you. How nice is that? Doesn't quite make you lunch just yet, but it will work that out for you. Now, one other thing as well is we need to work out the interquartile range. Okay, so the interquartile range is the difference between Q3 and Q1. Okay, so that's equal to Q3 minus Q1. Okay, Q3 is 7.5, Q1 is 1.5, 7.5 minus 1.5, and the value is 6. Okay, and that gives us a way of being able to determine, I guess, the spread of scores or the dispersion of scores without including sort of the endpoints. So the interquartile range is different to the range. Remember, the range is the maximum minus the minimum. The maximum and minimum could be outliers. We may have a problem with that. Outliers are quite nasty values. All right, we've got to be very careful with those values because they could really disturb the calculations here and may not give us a true picture of what's going on. But working out the interquartile range, for example, cuts out the outliers, so we have a truer picture as to what's going on with regards to how the scores are spread out. Okay, so that's it.